Welcome everyone to Weld Fab World. I'm glad you're here. This is lecture 1 of our 18-part series on ASME Section 9, the qualification standard that underpins virtually all pressure-containing fabrication under ASME boiler and pressure vessel codes. Before we get into the technical material, let me tell you why this first lecture matters more than it might look. Part QG is what I call the foundation layer of the entire code. Every rule you will encounter later, in Part QW for welding, in Part QB for brazing, and in Part QF for plastic fusing, ultimately rests on what Part QG defines. If you don't understand QG, the rest of the code will feel like rules without reasons. In this lecture we are covering paragraphs QG 100 through QG 106. These 6 paragraphs are just a few pages in the code, but they carry enormous weight. They tell you when Section 9 applies, what a WPS must contain, what a PQR actually is, who keeps the records, what the 3 types of variables mean, and who is ultimately responsible when a weld procedure fails. Let's begin. Let me orient you to the structure of this lecture before we dive in. We have 6 topics mapped to 6 code paragraphs. QG 100 covers scope and applicability, which construction codes actually reference Section IX, and what that means in practice. QG 101 covers procedure specifications, what a WPS must contain and how variables are defined within it. QG 102 covers procedure qualification records, the PQR, what it records and why a single PQR can support multiple WPS documents. QG 103 covers performance qualification records, WPQ retention and the authorized inspector's access rights. QG 105 covers variable classification, the 3 types, essential, supplementary essential, and non-essential. And QG 106 covers organizational responsibility, who qualifies, and why you cannot simply adopt another company's procedure. Think of these as building blocks. Each one sets up the next. By the end of this lecture you will have a complete mental model of how qualification works at the highest level before we go deeper into welding-specific rules in the lectures ahead. Let's open the code. QG 100 opens with this statement. This section contains requirements for the qualification of welders, welding operators, brazers, brazing operators, plastic fusing operators, and the material joining processes they use. For the construction of components under the rules of the ASME Boiler and Pressure Vessel Code, the ASME B31 codes for pressure piping, and other codes, standards, and specifications that reference this section. The key phrase there is, that reference this section. Section 9 does not apply automatically to all welding everywhere. It applies only when a referencing construction code explicitly calls it out. So which codes reference it? On the left side of the slide you can see the main ones. ASME Section 1, Power Boilers. ASME Section 3, Nuclear Components. ASME Section 4, Heating Boilers. ASME Section 8, Divisions 1, 2, and 3, Pressure Vessels. This is the most common one you will encounter. ASME Section 11, Nuclear and Service Inspection and Repairs. ASME Section 12, Transport Tanks. ASME B31.1 and B31.3, Pressure Piping, when those standards explicitly reference Section 9. Now equally important is what Section IX does not apply to. It does not cover structural welding under ASD 1.1. That standard has its own qualification rules. It does not cover pipeline welding under API 1104. And it does not cover welding in any application where no ASME construction code serves as the design basis. This matters in practice. I have seen engineers apply Section IX qualification requirements to structural steel work and wonder why the rules don't quite fit. They don't fit because Section IX was never written for that application. Now, a very important rule that the slide calls the precedence rule. QG 100b states, whenever the referencing code, standard, or specification imposes qualification requirements different than those given in this section, the requirements of the referencing code, standard, or specification shall take precedence. What this means is that Section 9 sets the floor, the minimum baseline. But a construction code can impose additional requirements on top of it, and those additional requirements win. For example, ASME Section 8 Division 1 allows you to follow Section 9 directly for most welds. But ASME Section 3 for nuclear work layers on additional requirements. Section 9 alone is not enough there. And finally, one of the most practically useful rules in QG 100, the transferability of qualification documents. A WPS, PQR, or WPQ prepared under one ASME construction code may be used for any other ASME construction code. If you qualify a procedure for Section 8 pressure vessel work, that same qualification is valid for Section I power boiler work, no requalification needed. That is a significant time and cost saving, and it is explicitly built into the code. Procedure specifications, the WPS, QG 101. QG 101. This paragraph is titled Procedure Specification, and it gives us the definition that everything else hangs on. The code says, a procedure specification is a written document providing direction to the person applying the material joining process. Notice what it says, direction to the person. A WPS is not a record of what was done. It is an instruction set. It is what the welder reads before picking up the electrode. That distinction matters. For welding, the procedure specification is called the Welding Procedure Specification, or WPS. The recommended form is QW 482 in Appendix B of Section IX, non-mandatory, but strongly recommended and used by almost everyone in industry. What must a WPS contain? Look at the list on the slide. The WPS must address the welding process, SMAW, GTAW, GMAW, SAW, and so on. The base metal, identified by P number and group number, with the thickness range qualified. The filler metal, F number, A number, SFA classification, and the AWS class. Joint design, groove type, backing, fit-up tolerances. Position, the qualified welding positions and weld progression direction. Preheat and interpass temperature, the minimum preheat and maximum interpass temperature. Post-weld heat treatment, temperature range, time at temperature, and heating and cooling rates. Electrical parameters, current type, polarity, and the ranges of amperage and voltage. Technique, stringer or weave bead, maximum bead width, cleaning between passes. Now beyond the content, there are three critical rules the code imposes on a WPS. Rule 1. The WPS must exist before production welding begins. You cannot write it retroactively. It must be physically available at the workstation. This sounds obvious, but it is one of the most common audit findings. A company starts production welding, then writes the WPS after the fact. That is a code violation. Rule 2. The WPS must address all applicable variables, essential, non-essential, and supplementary essential when toughness testing is required. You cannot selectively fill in the easy ones and skip the rest. Rule 3. The WPS must reference the procedure qualification record, the PQR, that supports it. If you subsequently change an essential variable in the WPS, the existing PQR no longer supports it and you need a new PQR. The link between WPS and PQR is formal and must be documented. Procedure Qualification Records, QG 102. Now we get to the PQR. If the WPS is the instruction set, the PQR is the proof that the instruction set works. The code defines it precisely. The procedure qualification record documents what occurred during the production of a procedure qualification test coupon and the results of testing that coupon. Let's walk through the 4 steps on the slide. Step 1. Weld a test coupon. You start with a proposed WPS. We call it a PWPS, lowercase p, and you use it to weld a test coupon. The critical point here is that you must record the actual values used during welding, not the target values, not the range from the WPS, but what actually happened in the test. If the target current was 120 amps but the actual average was 118 amps, you record 118. Step 2. Mechanical testing. Test specimens are extracted from the coupon and sent to a qualified testing laboratory. At minimum, you will perform tension tests and guided bend tests. When the referencing construction code requires it, and for many pressure vessel applications it does, you also perform impact tests to evaluate toughness. Step 3. Record on the PQR form. Everything goes on the PQR: actual welding variables, test results, pass, fail status, and the certifying signature. The non-mandatory form is QW483. The code requires that the organization certify the PQR, and that certification is a legal act. The code states the PQR shall be available for review. It is a permanent document. Step 4. PQR supports the WPS. Once certified, the PQR formally supports the WPS. And here is an important and very practical point. One PQR can support multiple WPS documents, provided that all the variable ranges listed in those WPS documents fall within what the PQR qualifies. Conversely, one WPS can be supported by more than one PQR. For example, if you used multiple test coupons to establish different thickness ranges. Now the 3 critical rules at the bottom of the slide. First, the PQR cannot be altered or modified after signing. It is a legal permanent record. If you later discover an error, you may correct a genuine editorial mistake, but you cannot revise actual test data. Falsifying a PQR is code misconduct. Second, one PQR can support multiple WPS, as we discussed. Third, the test laboratory must be acceptable to the manufacturer. Section 9 does not require a specific accreditation for the test lab, but the manufacturer takes responsibility for the lab's work. Performance qualification records, record keeping, QG 103. QG 103 and QG 104 deal with a different type of qualification, not of the procedure, but of the person performing the weld. The code puts it cleanly. The purpose of qualifying the person who will use a joining process is to demonstrate that person's ability to produce a sound joint when using a procedure specification. This is the performance qualification. The record of it is called the Welder Performance Qualification Record, or WPQ. This slide maps out the 3 documents, WPS, PQR, and WPQ, across 3 columns. Who retains them, for how long, and on what form. The WPS is retained by the manufacturer or contractor. It stays active for the life of the WPS. Best practice, and most quality programs require this, is to retain it permanently even if the WPS is withdrawn. The PQR is also retained by the manufacturer or contractor that performed the qualification test. Duration. Permanently. A PQR qualified today could support a WPS written 20 years from now if the variables match. There is no expiry on a PQR. The WPQ is retained by the manufacturer or contractor that employed the welder during the test. Duration. While the qualification remains valid, based on the continuity requirements of QW322, but best practice is to retain it permanently even after expiry. Now the audit requirement at the bottom. This is important and I want you to remember it. All records, WPS, PQR, and WPQ, must be available for review by the authorized inspector, or AI, at any time during their inspection. The code says available for review. There is no advance notice requirement. An AI can walk into your fabrication shop and ask to see any of these records on the spot. If you cannot produce them, that is a non-conformance. In practice, well-run fabricators maintain a document control system where these records are indexed and retrievable within minutes. The AI knows this, and they will test it. Variable classification. The 3 types, QG 105. QG 105 is arguably the most important paragraph in Part QG for day-to-day engineering work, because it governs the single most common question in weld procedure management. If I change this parameter, do I need a new PQR? The answer depends entirely on what type of variable is being changed. The code defines 3 types. Essential variables, QG 105.1. The code states, essential variables are conditions in which a change, as described in the specific variables, is considered to affect the mechanical properties, other than toughness, of the joint. If you change an essential variable, you must requalify. New test coupon, new mechanical testing, new PQR, no exceptions. Look at the examples on the slide. Changing the welding process, for example from SMAW to GTAW, is essential. Changing the P number of the base metal is essential. Changing the F number of the filler metal is essential. Adding or deleting PWHT is essential. Changing current polarity is essential. Supplementary essential variables. QG 105.3. The code says, supplementary essential variables are conditions in which a change will affect the toughness properties of the joint, heat affected zone, or base material. The critical qualifier. These variables only become additional essential variables when the referencing code requires toughness testing. If your application does not require impact testing, and many Section 8 Div. 1 applications do not, supplementary essential variables are simply not applicable. They do not exist for your procedure. When toughness testing is required, supplementary essential variables carry the same weight as essential variables. Any change requires a new PQR. Examples include a group number change, a change to post-weld heat treatment temperature range where toughness is a concern, a change in heat input beyond qualified range. Non-essential variables, QG 105.4. The code defines these as conditions in which a change is not considered to affect the mechanical properties of the joint. You can change a non-essential variable without requalifying. You simply revise the WPS, update the revision number, document the change, and continue production. No new test coupon required. Examples include changes in joint design or groove angle, addition or deletion of backing material, changes in cleaning method, changes in travel speed within heat input limits, changes in pass sequence, changes in electrode diameter within the same F number. This distinction, between revising a WPS and requalifying a PQR, has major cost and schedule implications. A PQR qualification can cost tens of thousands of dollars and take weeks when you account for test coupon preparation, laboratory testing, documentation, and AI review. A WPS revision costs a few hours of engineering time. Knowing your variable classifications protects both. How to read the Article 4 variable tables, QG 105. Now I want to show you something practical. How to actually use the variable tables in Article 4, because this is what you will be doing every time you review a WPS change. Each welding process has its own variable table. For SMAW, it is table QW 253. For GTAW it is QW 256. For GMAW it is QW 255, and so on. The structure of all these tables is the same. Look at the table on the slide. It has 5 columns. Paragraph, the QW 400 series paragraph that defines the variable. Brief of variable, a short description of what changes. Essential, WPS and PQR. Marked with X if the variable is essential for procedure qualification. Supplementary essential. Marked with X if the variable becomes essential when toughness testing is required. Non-essential, WPS. Marked with X if the variable requires only a WPS revision. There is also a WPQ-only column for variables relevant only to performance qualification. Let's read a few rows together. Row QW 403.1, change from one P number to another, has an X in the essential column. That means any time you change the base metal P number, you need a new PQR. Full stop. Row QW 403.6, T limits for toughness procedures, has an X in the supplementary essential column. This only matters when toughness testing is required. Row QW 402.1, change in groove type, V to U groove, for example, has an X in the non-essential column. You can change your groove geometry and revise the WPS without requalifying. Row QW 407.1, addition or deletion of PWHT, has an X in the essential column. Adding or removing post-weld heat treatment changes the mechanical properties of the joint fundamentally, so requalification is required. The rule for blank cells. Blank means the variable does not apply to that process. For example, shielding gas variables are not applicable to SMAW because SMAW has no shielding gas. So QW408.1 would be blank in the SMAW table. When you are evaluating a proposed WPS change, your workflow is: identify the variable being changed, find its paragraph number, look it up in the correct process table, read the column it falls under, and act accordingly. That is the entire decision process, but you need to be looking at the right table for the right process. Organizational responsibility, QG 106. QG 106 is where the code assigns legal accountability. It is short in text but carries large implications. The core rule, QG 106.1, states, each organization is responsible for conducting the tests required by this section to qualify the procedures that are used in the construction of components. And QG 106.2 states, each organization is responsible for the supervision and control of material joining performed by persons for whom they have operational responsibility and control. This responsibility cannot be delegated to another organization. Let's unpack the 4 points on the slide. Point 1. Cannot adopt another company's PQR. Company A cannot take Company B's WPS and PQR and simply start using them in production. Even if the processes are identical, the materials are identical, and the welder is the same person. Company A must run their own qualification test, produce their own PQR, certify it themselves, and take ownership. This is one of the most frequently misunderstood rules in Section IX, and it is a common audit finding. The code does provide a narrow exception in QG 106.4 for simultaneous procedure qualifications, where 2 or more organizations expressly conduct a qualification test jointly. But this requires upfront agreement, simultaneous supervision by representatives of each organization, and each organization certifying their own PQR from the shared test. It is not the same as adopting someone else's existing PQR. Point 2. Qualification is company-specific. A PQR belongs to the company that produced it. If your lead welding engineer moves to a competitor and takes their expertise with them, the PQRs stay with you. The knowledge is portable, the legal documents are not. Point 3. WPQ has limited portability. This is the one exception. Welder Performance Qualification Records, the WPQ, may be accepted from a previous employer under certain conditions. The records must be available. The continuity requirements must have been met since the original qualification date, and the new employer must formally accept them. But even when a new employer accepts a transferred WPQ, that employer takes on full responsibility for that welder's qualification from that point forward. Point 4. Supervisory responsibility during tests. The code requires that the manufacturer provide qualified supervision during all qualification test welding. The supervisor verifies that the actual variables recorded on the PQR are accurate representations of what happened during the test. QG 106 makes clear that the personnel performing this supervisory role must have the knowledge and competence to do so. The code specifies knowledge of Section IX requirements, knowledge of the quality program, and competence appropriate to the scope of work being supervised. Records of their qualifications must be maintained by the organization. How QG 100 to QG 106 connect, the qualification flow. Now let's bring it all together. This slide shows you the complete qualification flow from start to finish, and it maps every step back to the code paragraph that governs it. Walk through it with me from left to right. It starts with a referencing construction code, say, ASME Section 8 Div. 1 for a pressure vessel, calling for Section IX compliance. That is QG 100. The manufacturer identifies the need for a WPS. They are about to weld P1 carbon steel in the 5G position using SMAW. They need a qualified WPS to govern that work. That is QG 106, organizational responsibility. They write a proposed WPS, the PWPS. It describes everything: process, base metal, filler metal, joint, position, preheat, PWHT, electrical parameters, technique. That is QG 101. They weld a test coupon and test it, mechanical tests, bend tests, and impact tests if required. They record every actual variable. That is QG 102. They record the results on the PQR, certify it with a signature, and it becomes a permanent legal record. QG 102 again. The PQR formally supports the WPS. That link is documented. QG 101 and QG 102 together. The qualified WPS is issued to production. It is physically at the workstation before the first production weld is struck. And finally, WPS, PQR, and WPQ are retained permanently and made available to the AI. QG 103. The summary box on the slide captures the key relationships to remember. WPS equals instructions before welding. PQR equals evidence after test welding. WPQ equals the welder's personal qualification record. The PQR supports the WPS, not the reverse. And the variable decision rule, essential variable changed, right pointing arrow new PQR required. Supplementary essential changed, right pointing arrow new PQR if toughness testing is required. Non-essential variable changed, right pointing arrow revise the WPS only. Special process variables and the WPS change decision tree, QG 105. Before we wrap up the content slides, I want to complete the variable picture by covering one more category, special process variables, and give you a decision tree you can actually use in practice. QG 105.5 defines special process variables as conditions that apply only to special processes. The code covers these in the QW280 to QW290 series. These processes include laser beam welding, electron beam welding, friction stir welding, and temper bead welding, among others. For these processes, the special process variables are in addition to, not instead of, the regular essential and non-essential variables. And critically, a change in a special process variable always requires requalification, regardless of whether toughness testing is required. There is no conditional trigger here as there is with supplementary essential variables. Now look at the decision tree on the slide. Use this every time a WPS change is proposed. The first question is a change required to the WPS? If yes, proceed. The second question is, what type of variable is being changed? If it is essential right pointing arrow new test coupon, new PQR required. Full requalification. If it is supplementary essential right pointing arrow ask, is toughness testing required by the referencing code? If yes right pointing arrow new PQR required. If no right pointing arrow revise the WPS only, no retest. If it is non-essential right pointing arrow revise the WPS with a new revision number or new WPS number. No new test, no new PQR. This decision tree seems simple when laid out this way, but in practice people skip steps. They assume they know the variable type from memory. They don't check the correct process table. They confuse the welding process they're looking at with another process they worked on last month. Use the table, every time, even when you think you know the answer. Let's consolidate what we covered today into 6 key takeaways. 1. Section 9 applies to pressure containing fabrication only, specifically when a referencing construction code calls it out. Section 1, 3, 4, 8, 11, 12, and B31 piping codes. Not to structural welding under ASD 1.1 or pipeline welding under API 1104. 2. A WPS must describe all variable types, essential, non-essential, and supplementary essential when required. It must reference its supporting PQR, and it must exist before production welding starts. Not during, not after. 3. A PQR is a permanent, unalterable legal record of the actual variables used in the qualification test and the actual test results. One PQR can support multiple WPS documents as long as the variable ranges are consistent. 4. The WPS, PQR, and WPQ must all be retained by the manufacturer or contractor and made available to the authorized inspector on request. No advance notice required. 5. Essential variables require a new PQR when change. Supplementary essential variables require requalification only if the referencing code mandates toughness testing. Non-essential variables require only a WPS revision. Get this wrong and you have an unqualified procedure in production. 6. Each company must qualify its own procedures. You cannot adopt another firm's PQR. WPQ records have limited portability but come with full responsibility transfer to the new employer. In the next lecture, Lecture 02, we will cover QG 107 on ownership transfers and what happens to qualification records when companies change hands, QG 108 on the use of qualifications made to previous editions of the code, and QG 109, which is the complete definition section. That definition section is longer than it looks and has some important practical content in it. Thank you for watching. If you found this useful, please subscribe to the WeldFab World YouTube channel and visit weldfabworld.com for written references and supporting material. That is all for Lecture 1. Just a quick note on references. Everything in this lecture is drawn directly from ASME BPVC Section IX, 2025 edition, Part QG, paragraphs QG 100 through QG 106. The QW 482, QW 483, and QW 484-485 forms are in Appendix B of the same document. Always refer to the current edition of the code for official requirements. This lecture is for educational purposes. If you have questions, drop them in the comments below or reach out through weldfabworld.com. I will see you in Lecture 2.